Now we're on to the other comparison test. So this is called the limit comparison test. So first off, both of the two series that I'm doing the comparison test with, they both have to be positive. So both positive, no negatives in there. So what we're going to do is we're going to be taking the ratio. We're going to be taking the limit as n goes to infinity of one of them divided by the other one. And then I'm going to get a number out of that, and I get a number c. Okay, so first off, this number c has to be bigger than 0 and finite, which means not infinity. So if you get a number c that's negative, or if you get a number c that's infinity, test doesn't work. Okay, so this number c that you're going to get from the limit has to be bigger than 0 and a finite number. So what's the conclusion? Then you get that they both converge or they both diverge. A very different kind of a result. So they both do the same thing. So I'm just going to kind of use this Bodeusah. Oh yeah, that's right. What does that mean again? They both do the same thing. Okay, so when is this test useful? When the basic comparison test fails. So let's look at this one. So you got happy-go-lucky. You're thinking, oh, there's not a problem here. I can pull off that 2, right? Pull off that 2, that one's smaller. I get 1 over n. What do I know about 1 over n? From 1 to infinity, this diverges by p-test. Oh, wait a minute. Here I have the larger diverging BCT failed. So far you've always gotten the basic comparison test working. Now you're going to get it that it fails on occasion. Okay, it has to be the larger converging. Okay, so now I'm ready to go with my limit comparison test. So my limit comparison test needs 2 sums. So one of them has to be your original equation. And here's the other one, ready to go, right? So I'm going to take the limit as n goes to infinity of one of them divided by the other one. It doesn't matter which one you put on top. So I'm going to put the original divided by 1 over n. Okay, these are always fractions, so I'm always going to be multiplying by the reciprocal, right? So I get n squared over n cubed plus 2 times n over 1. Okay, so now I'm taking the limit as n goes to infinity. So I'm doing highest powers. So highest power from the numerator, n cubed. Highest power from the denominator, n cubed. I get 1. Okay, so what was the deal? The limit was a number, has to be bigger than 0. Yep, it is, and it's not infinity. Yep, that's good. So what does this mean? I get therefore they both do the same thing. So I look back in my work. Oh yeah, I got this one diverges. So I can conclude this one diverges also by the limit comparison test. You don't need to write this one again. It's there in your work. So it's all set. So you've got this one diverging. You've got the ratio with the limit comparison test. You show that it was bigger than 0. Then you get conclude that this one diverges also. Okay, so let's try this one. So this one looks like a nice candidate for a basic comparison test, right? Because pulling one number off, that makes it smaller here. So simplifying, I get 1 over n cubed. And so then if I look at the summation of 1 over n cubed, this converges by p-test. So let's look what I have here. Oh no, this gives me the smaller converges, BCT fails. Can't have the smaller converging to get a result. Okay, so what am I ready to do? I'm ready to go do the limit comparison test. So the limit comparison test, I've got this one here, and I've got this one, right? So I'm going to take the limit as n goes to infinity of the original guy, and then divide it by this, which is the same thing as saying multiplying by this, right? Dividing by 1 over n cubed is the same thing as multiplying by n cubed over 1. Okay, so now I'm ready to do highest powers because I'm taking the limit as n goes to infinity. So I get n to the 4 over n to the 4th minus 2. Highest powers, I get 1. It's going to happen a lot. You're going to get 1 an awful lot. But that's good because that's a number bigger than 0. So therefore, they both do the same thing. You don't need to write this. I'm just kind of trying to help you reinforce what this means, right? So you can at least think that. Then you say, okay, what did the other one do? Oh yeah, that one converged. So therefore, so you need to write it. This one converges also by the limit comparison test. Okay, one more here on this page. So let's start with our basic comparison because it looks like it might work, right? There's just one number to pull off. So this has more in the denominator. This is the same thing as saying 5/3 to the nth power. What do I know about the sum of 5/3 to the nth? Oh yes, that's a divergent geometric sum. So that's not good because this gives me the larger diverges. So BCT fails, right? You don't have to write this. I'm just kind of reinforcing what you know. So now I'm off to do the limit comparison test. So if I take the limit as n goes to infinity of the original, and then I'm going to multiply by the reciprocal of this, right? 3 to the n over 5 to the n. Okay, so let's see what happens here. So I have limit as n goes to infinity. So I have 5 to the n times 3 to the n. And I'm taking highest power. So this 2 fades away in the distance, right? 3 to the n, 5 to the n. I can see canceling going on, so I can see I get 1. So that gives me bigger than 0. They both do the same thing. So what must this one do? The original one, because I have this one here diverges, I can say this diverges also by LCT.